to building a Game Boy Emulator in Python. I'm going to start off by showing you a bunch of stuff that I've done in the meantime. So I've done a lot of instructions, and I've moved the instructions to separate methods, so it wouldn't be like in between the execute function. And on the init function here, the instructions are set on the object. And then all the instructions are in this dictionary. And I've built a lot of them, but not enough. So what do we have here? Yeah, so this is all of them. And to keep a little bit more better track of where I am, I've built this little file so I can see what instructions I've implemented. And so for instance, these 3 rows, these are mostly all load instructions. You can see the table over here. So these are almost all load instructions, and I think I've got them all except for halt. And then I do have a lot of instructions that are not in this map yet, but I've done most of them I've done by category. Another thing that I was working on is this one. Decrement is a little bit tricky. And another one I've been working on is this one, this interesting one, rotate left. So this is basically like a shift, but the last bit is rotated through the first bit again. And in this particular case, the carry also counts as like the 8th bit, and that will be brought to the 0th bit. So that's just something interesting. Also stuff like this, call and pop, so we can interact with our stack now. And what else? I've been fiddling also a little bit with the operand fetching stuff, but you know, whatever works there. So yeah, I'm just gonna run a ROM now and see how far we get. Main, and so you see a lot of output going on here. It's already doing a fair amount of work, and we'll see when it breaks. So this is taking longer than I expected. maybe it's because it's in a loop. Oh yeah, I remember now. I had a problem because I was putting something wrong in this register, because you can actually see it's 2 bits overflown. So that's not that's not supposed to happen, of course. But I haven't figured out yet where this goes wrong. So if you have a look, we see that we have this instruction, and it goes fine, and then this one, and then it breaks. So I want to know exactly what instruction is being executed. I think it's one where I already was trying to fix it a little bit. Let's search for that. So over here, decrement. So this is, for instance, a value that's being put back. Instruction deck n. So it's a little bit more clear who is messing up here. Yeah, instruction decrement. So this is fine. This is fine. What is B? I need to know what register B is. Oh. Yeah, this is not going well. Why is this not working? I'm going to print the arguments that I have, because there might be something weird in there. I'm just going to do it as a normal thing, like this. I'm going to decimal. No, string. So what happened here? B is FF, or is it? Who knows? But for some reason, the register of A is being, or the flag register is being messed up. So the argument is B. Yeah. So it's very strange that it's actually not being saved there. Because here is a set register 8. Yeah, A set A, B set B, C set C. I've built also this in, so that I have a little bit of safety. And now we're at it, I'm also going to put it over here. Going to do a check in here. Self, let's set native, and then we get a value. And then we want to see 6 digits. So if it's larger than just our usual 4 hexadecimal characters, so I can see that. Okay, so this is wrong. The value of A is wrong. Why is the value of A wrong? Here it's okay. This is okay, this is not. So here we have CE, but then suddenly here it's 33B. So somewhere along there it's messed up. We set flags. Okay. A little bit stuck here right now. Let me think. Yeah, for now I think I'll just do this, and I'll paste that that safety in all my setters, so we can see where it goes wrong. Yeah. So what do we get here? This instruction is actually messing it up. Rotate left. And this is the piece of code that messes it up. And it's actually not that strange why this is happening. So let's go there. Yes, over here. So, okay, why does this go wrong? I can see it now. So we're trying to set A, and we're getting A, and then shifting it one left, and then adding a 1 in the beginning if the first bit of A is 1. So that is if the carry is set, carry flag, because the carry flag gets shifted over to the first position. And the way I done is I just check that with an if statement, and then in both these cases this is the way I build it. But I can see why it didn't work before, and that is because if this already has a 1 in the position of the 7th bit, so this bit, then will get shifted over to the 8th bit. But we have an 8-bit system, so we don't have that bit. So we need to mask it. It's not that hard, I've done that before. So all higher bits will drop off. But if it's actually if it's higher than 256, we need to set the carry bit, I think. So I'm just going to look up the specification for this particular instruction. Relay. So yeah, the carry will contain the old data. That's already been taken care of. So all I need to do is to make sure that I don't mess it up, and I will do that by masking it with something like this, 0x00ff, and this will make sure that this byte is always 0 because I end it with 0, and this byte will be whatever it was because I'll end it with all ones. So I'll do that. So put it there. I'll do that here as well. And 0x00ff. And we're back in business. I hope. So just checking the instructions. I'm going to remove some of these debug statements and add a couple more so I can do a little bit, can see a little bit better what the instruction is being executed. But at least no more overflows on the registers. So this is gone. Gone. Actually, gonna keep this. because it's nice and safe. And if need be, then we'll just remove it. This is not necessary, I think. Cool. Okay, this is all good now. Now look at our main file again, and I think I'll have I'll put a debug statement here. Print CPU dot get register 16 broken counter. So it's not really doing much. It seems that we're stuck in a loop. Nine 9B, 9C, 9D, 9F, A0. So what is actually happening? Let's have a look. Instruction A0. I have this handy post that talks about the bootloader. And at A0 there's a decrement. Okay, that's cool. That's this decrement B. So B is, well, it's already 0. And then apparently after B it is still 0. So it's 0 over here. It's 0. It's 0. But it should flow over. So that's not good. So we need to have a look at our decrement instruction and the flags that need to be set. So what is happening here? So the idea is that I will set the value to be what we already have in the register. That's register B. So this will be fetched -1, and then mask it. So I think what happens is, put it here, is old value and the new value. The old value will probably be something like 0, and the new value will still be 0. 2x, let's make it 4x. We want the self.get register 8 arguments. One, two, three. Wait, and a new value. Val. Let it go for a while. And what do we see? We see old value 0, 0. New value FF. But then B is 0 once again after a short while. So what is supposed to happen here? From A0, decrement B, jump if not 0 to 9, 8, push BC on stack, rotate left register C through carry, rotate accumulator through carry flag, pop to register, well, it's very complicated. Let's have a look at what they explain here. So what I think is very important is that we need to check if we are setting our 0 flag. So if our new value is 0, then we actually change the 0 flag. And I want to make sure that we do that. just gonna change this a little bit. So if value, then I will set the flag. If not value, then we'll reset the flag. And I'll print. Very obvious to spot in our debug. Yeah, that's better. So we did a couple of loops, maybe one, and then we hit an instruction that we didn't have before, 22. Let's have a look. It's hard to spot there. Take our nice table. We look at 22. That's 2 and 2. Load A into HL. That is this one. So let's have a look at that. Opcode 22. Yeah, we don't have that yet, so let's build it. So we have a function, load 8 something, and what does it need to do? Put A into memory address HL, and then increment HL. Okay, so load and increment LDI 8 and then HLA. Yeah, it's very specific instructions. I'm not going to make this very generic. So cycles takes 8 cycles. Program counter is increased by 1. Yeah. Go up. We already had a load and decrement. It's this one. So we're going to use that. Load and increment HLA. So we're going to write to yeah, and then we're going to increase, but we're also going to mask it with a bit mask. Don't need the parentheses in there. So what this prevents, if this flows over, so if there's a value of FFFF in the HL, and you do it +1, because we are on a 64-bit system, it will just put it into this, it will just expand 1, but we need to block that from happening. So that's why we use this masking to prevent it from increasing. So then if you have this and you do +1, it will be back to 0. Because these will all be 0, 0, 0, 1, but then the 1 will be blocked off, so we just have this. Oh, 1 bracket too much. And then we have another missing instruction, number 23. Two, 3. Increment HL. Let's have a look here. Yeah, that's right. So they increment HL twice. And they do it also here. Yeah, so they are basically loading 4 bytes. Load a byte, increment HL another one, and then do it again. So it's kind of interesting that we didn't have an increment instruction yet, because that is an extremely often used instruction, increment, because you basically need it for loops. So function I think we'll call it inc_n. No, it's inc_hl. Yeah. Inc16 and n register HL in this case. It takes 8 cycles. And 1 program counter. But we have this function 4 times. So we'll build all 4 in one go. 23, 13, this one is EE. Then we have 0, 3. And this one will be BC. Now we have 33. So that's over here. That's SP. So we can increment stack pointer also. Cool. Go to our functions. What do we have here? Yeah, we have inc will be after decrement. So inc 16 and n. We'll set a register 16. Which register? R0. The value will be, first we get the value that we had. Get register 16. Same argument. Yes. And then we do +1, of course, but we also do the masking again. Same thing as before. So we mask with 00FFFF, 16-bit. Yep, and this will work. And we'll test it, and then we'll also change our file where we keep all instructions in an overview. And new instruction C9. What is C9? Return. All right. That's interesting. So then I'll assume that our decrement worked. I think, yeah, it worked. So it set memory location 10, 8010 to 3B and memory location 8012 to 3B. So let's have a look at instruction C9 after we update this file. So we did 03 up to 33. So that's that. So let's look at instruction C9. Pop 2 bytes off the stack and jump to that address. C9 is supposed to go here. C9. And that will be return. Will cost 8 cycles. And 1 program counter increment. And I'll put this after pop. So basically what we will do is we set our program counter to be it's basically like a pop, but with the argument of the stack pointer and then jump. Oh, the screen is black, I see. I'll check. This seems to be working. Well, it's good to know that everything is still working. So we'll implement our return. So we need to basically just set register, or basically set program counter with 2 bytes from the stack, so that's a memory. So we need to go into self.mem read word, and the address where we need to read is where the current stack pointer is. So that's the address. That's the pointer. And that will be set into the program counter. And then what we need to do is we need to increment the stack pointer. So that's what we had plus 2. So what you can see here, it's very similar to pop_nn, where we pop 2 bytes of the stack into a register, but here we just pop it into the program counter. The reason I'm not reusing this function is, well, one, for speed, and second is to have it separate. So if something needs to change because it's special return, then I can easily edit it. And because I could have also used the same function as this one and give it a SP as a parameter in args, but I like this a little bit better. What's going on? Key error 175. In XOR. So what is going on here? Line 90. So what's going on here? Oh. Just like that. Whoa, rag is an int. That's not good. This is supposed to be a string. So who is being called? Current instruction. Whoa. Instruction 1201. Well, that's interesting. Let me check what instruction that is supposed to be, because that's already in the. I think that is already a cartridge instruction. So from the game, not from the BIOS. Let me check the memdump. XXD. Oh, first go to the right folder. Memdump. Yeah, so this is basically a print of the memory, and you see that here is the cartridge memory, part of it at least. And that starts right here at 0, 100. Oh no, sorry, yeah, this is where it starts. and well, it appears to have jumped to instruction A7 to 1201. So let us have a look here. Yeah, that's the return. Let me just check if it tells us anything about that. So it seems to me that's not really what is supposed to happen, because we are supposed to go from let me have a look. The A, where's the jump? A0. No, it's not A0, it's A7 return. But who has called this method is the one who popped his thing on the stack. There's 3B. So if I have a look what's on the stack pointer, points to FFFC. So let's have a better look at our return. So what I want to do is I want to ask, I want to see what address the stack pointer is at and what the actual content of that word is, the 2 bytes. So we can see if the position in the program that it jumps to is sensible. So I will print the stack pointer. And I will also print what's in the stack pointer actually. So like this, plus self.mem.read word self.get sp. So we need to use a better so 0 4 characters long. Use a tabulator. 0x also 4x. course I need to use the format error. Format. We're not doing well today. Forgot a bracket. Yep, got an underscore. Okay, so we're back to our original error. We can see that the value that's in stack pointer is 1200. Interesting. I think that's not the way, because I actually think that what is put on the stack is actually 0012. So exactly switched around, if I'm correct. But sometimes that can be very hard to see because it doesn't actually need to have been shown up. 12. So now it's maybe interesting to see, I hope we can find that, is where this is being. So it will say mem 12, what is it? FFFC. And so that's the point where it's loaded into memory. So we'll, instead of, I will pipe our output into a file. And then we'll look in the file. And I will search for FFFC. Yeah. So here is where that information is being put into the memory. And let me get an editor out. So read. So this is the question. If I read from this address, do I get 0012 or do I get 1200? So, and this is something I've been struggling with the entire time I've been building this emulator. The documentation is really not clear about how bytes are read from memory. Because when you read 1 byte, it's obvious what happens. But if you read 2 bytes, then it's hard. So if I were to read 8 bytes, it would be easier. Let me show you. So then it will be, obviously it will be this, no doubt, right? But if I do read 16, do I read from here and then, yeah, so it's not very clear to me. Yeah, but what we can check if it's correct that we need to jump back to location number 12. So 12 is a really weird position to jump to, because there's no instruction that starts there. So maybe we even have more difficult plan, a more difficult situation on it. But there is another possibility, and that's this. So I want to make this clear for you. There is also FFF B. I don't know if that's being written to. I don't think so. No, it's not there. So yeah, this is a tough one. So I think I'll pause the stream for a little bit. I'll take a break. I'll try to figure this out a little bit, and then in like half an hour I'll be back. So thank you for joining me. If you have any comments, suggestions, ideas, anything like that, please do tell me. Especially if you have any knowledge about the subject. But even if you're just watching this and you don't know anything about emulators, but you do know something about Python, then do tell me your feedback. You can put the feedback here in the chat. You can send me a message on live coding. You can tweet me. So I'm very interested to see what you guys think about this, and see you the next time.